Hello everyone, welcome to my channel Learn and Inspire. I am Hariram, mathematics teacher. So in the previous class we discussed an introduction about polynomials of class 10 mathematics. So we learned degree of a polynomial, types of degree of a polynomial, and also a general form of a polynomial whose degree is n, value of a polynomial, and 0 of a polynomial. So based on these topics in today's class, so we solve problems from exercise 3.1. Okay, so let's start the first question. So here is the first question. If p of x is equals to 5x power 7 minus 6x power 5 plus 7x minus 6, find first one coefficient of x power 5, second one degree of p of x, third one constant term. So here are the three questions. So from the given polynomial we have to find all these three. So what is the first one given? Coefficient of x power 5. So first, before that, I write the polynomial p of x. Okay, so given p of x is equals to 5x power 7 minus 6x power 5 plus 7x minus 6. So what is the first one? So we have to write the coefficient of x power 5. So what is the coefficient of x power 5? So coefficient is nothing but the constant term before the variable. The constant before the variable. So x power 5 is the variable. So what is the constant before the variable? So that is a minus 6. So we have to represent that operation sign also. That is minus 6. So if it is plus 6, you can write simply as a 6. Understood? What is the coefficient of x power 5? Now the second one is degree of p of x. So p of x is nothing but a polynomial of x. So we have to consider the whole polynomial. In that polynomial, what is the highest degree? So in the given polynomial, what is the highest degree? So highest degree is 7. That represents a degree of polynomial p of x. Okay. Third one. So constant term. So what is a constant term in the given polynomial? Constant term is minus 6. So we have to represent that sign also. So minus 6 is a constant term in the given polynomial. Understood? So this is question number 1. Next, question number 2. State which of the following statements are true and which are false. Give reasons. So from the given statement we have to check whether it is true or false. The first one, the degree of the polynomial root 2 x square minus 3x plus 1 is root 2. Degree of the polynomial. So polynomial is given, so we have to identify the degree. So degree of the polynomial is nothing but the highest degree represents the degree of the polynomial. So what is the highest degree in the given polynomial? So highest degree is 2. But in the given statement, the degree is given as root 2. Is it true or false? Yes, it is false because the highest degree is 2, but here it is given as a root 2. So the statement is false. Okay, so understood? Second one, the coefficient of x square in the polynomial p of x is equals to 3x cube minus 4x square plus 5x plus 7 is 2. Coefficient of x square. So x square term is, so this one. And what is the constant before the variable x square? That is a minus 4. So minus 4 is the coefficient of x square, but here it is given as a 2. Okay, so this statement says it is false because the answer is minus 4, but in the given question it is given as a 2. So it is false. Third one, the degree of constant term is 0. Yes, already we have discussed in the introduction. The degree of a constant term is 0. So this statement says true. Okay. Next one. 1 by x square minus 5x plus 6. So 1 by x square minus 5x plus 6 is a quadratic polynomial. So is this a quadratic polynomial? No, because so it is the polynomial is in the denominator. So if I transpose this, it becomes x square minus 5x plus 6 whole power minus 1 x square minus 5x plus 6 whole power minus 1. Here the degree is minus 1. So the exponent should be always a positive integer. So here it is a negative integer. So it is not a polynomial. So the statement says false. Okay. Next, question number 5. The degree of a polynomial is 1 more than the number of terms in it. So this statement says the degree of a polynomial is 1 more than the number of terms in it. Suppose if I take a quadratic polynomial. So quadratic polynomial degree is 2. So now if the degree is 2, so it says that 1 more than the number of terms in it. That means, so if the degree is 2 and it is added 1 more than the number of terms, then it becomes 3 terms. Okay, so here the statement says it is a false. Why? Because so if I take x power 4 plus 5, x power 4 plus 5, so here what is the degree? Degree is 4. So is this a polynomial? Yes, we can say that it is a polynomial with a degree 4 and it has 2 terms. Okay, so here we should not relate with the degree and number of terms in it. So we should not relate a degree and number of terms in it. So this statement says it is a false. Okay, so this is question number 2. Next, move on to the third question. Next, question number 3. If p of t is equals to t cube minus 1, find the values of p of 1, p of minus 1, p of 0, p of 2 and p of minus 2. That means, so we have to substitute the values in place of t. So these are the values 1, minus 1, 0, 2 and minus 2. Okay, so first we write the given polynomial p of t is equals to t cube minus 1. So what is the first value? So we have to substitute. So put t is equals to 1, then it becomes p of 1. Okay, p of 1 is equals to, in place of t we substitute 1 cube minus 1. So 1 cube is nothing but 1 is multiplied 3 times. So this power represents the number of times multiplied by the number. Okay, 1 is multiplied 3 times. So 1 into 1 minus 1. So 1 is multiplying 3 times. So 1 into 1 is 1. 1 minus 1 is equals to 0. Okay, so next one, put t is equals to minus 1. P of minus 1 is equals to, so t cube minus 1 is the polynomial. So if I substitute minus 1, we get minus 1 whole cube minus 1. So here minus 1 is multiplying 3 times. So if I multiply minus 1 3 times, so we get minus 1 into minus 1 into minus 1. Again I write minus 1 here. Okay, 3 times here we are multiplying with minus. Minus into minus, plus, plus into minus, minus. If I multiply 1 3 times, we get 1. I write minus 1 as it is. Minus 1 is minus 2. Okay, so next, the third one, put t is equals to 0. So p of 0 is equals to, so t cube minus 1, that implies 0 cube minus 1. So 0 cube is 0 minus 1. 0 minus 1 is minus 1. Okay, next, fourth one. So put t is equals to 2. P of 2 is equals to 2 cube minus 1. So in place of t I am substituting 2. 2 cube minus 1. So 2 cube is 8 because 2 is multiplying 3 times. 2 into 2 into 2. 2 into 2 is 4. 4 2s are 8. 8 minus 1 is equals to 7. Next, fifth one. So put t is equals to minus 2. So p of minus 2 is equals to minus 2 whole cube minus 1. So if I multiply negative with the 3 times, so if I multiply minus 3 times, so we get a negative itself. Okay, now 2 cube is how much? 8. 8 minus 1, right, as it is. Minus 8 minus 1 is minus 9. So this problem is based on a value of a polynomial. So yesterday we have discussed the topic about value of a polynomial. by substituting the values in place of t. Okay, so this is question number 2. So next move on to the fourth question. Sorry, this is question number 3. Move on to the fourth question. Next question number 4. Check whether minus 2 and 2 are zeros of the polynomial p of x is equals to x power 4 minus 16. So this is a given polynomial, and in this polynomial we have to check minus 2 and plus 2 are zeros of the polynomial. Okay, so we have to substitute minus 2 and plus 2. So given polynomial p of x is equals to x power 4 minus 16. So first one we have to substitute minus 2. Put x is equals to minus 2. Then p of minus 2 is equals to minus 2 whole power 4 minus 16. Okay, so minus 2 is multiplied 4 times. Minus 2 into minus 2 into minus 2 into minus 2. So minus 16 I write as it is. Okay, so for understanding purpose I have written minus 2 4 times. Minus into minus plus, plus into minus minus, minus into minus plus. Okay, now multiply 2 into 2 4, 4 2s are 8, 8 2s are 16. Minus 16 right as it is. So 16 minus 16 is 0. Understood? Now I substitute plus 2. Put x is equals to 2. So p of 2 is equals to, so in place of x I substitute 2 power 4 minus 16. So 2 power 4 is multiplied 4 times. So we get 16 minus 16 equals to 0. So if I substitute minus 2, so we get 0, and if I substitute plus 2, we get 0. So from this we can say that minus 2 and 2 are the zeros of the polynomial. Zeros of the polynomial p of x. Understood? So next move on to the fifth one. Last question from exercise 2.5. Check whether 3 and minus 2 are zeros of the polynomial p of x when p of x is equals to x square minus x minus 6. So this is the question. So first we write a given polynomial. So given polynomial is p of x is equals to x square minus x minus 6. So what are the values to be substituted? 3 and minus 2. So first we substitute 3, x is equals to 3. So we get p of 3 is equals to 3 square. So in place of x I am substituting 3 minus 6. 3 square is 9 minus 3 minus 6. I write as it is minus 3 minus 6. Now 9 minus 3 minus 6 is a minus 9, because here we are adding two negative integers. So result will be negative, and adding the two numbers 3 plus 6 9. 9 minus 9 is 0. Okay, next so we have to substitute minus 2. Put x is equals to minus 2. P of minus 2 is equals to minus 2 square minus value of x is a minus 2. So I write again minus 2 minus 6. Okay, so minus we have written as it is, and in place of x we have substituted minus 2. So minus 2 whole square. Minus 2 is multiplying 2 times, we get a positive. 2 square is 4. Minus into minus plus 2 right as it is, and minus 6. 4 plus 2 is 6. 6 minus 6 is equals to 0. So from this we can say that 3 and minus 2 are zeros of the polynomial. 3 and minus 2 are zeros of the polynomial p of x. Understood? So these two questions are very important for 2 marks. So these are the problems from exercise 3.1. I hope you all might have understood these problems, and if you have any doubts related to this exercise 3.1, you can message me in the comment box. And in the next video we shall discuss exercise 3.2, and if you like the video, please share and subscribe to my channel. Thanks for watching.